Hello science fans, get ready to explore the fascinating world around us, one reaction at a time. Today, let's dive into the world of chemical reactions, the processes that shape everything from the smallest cell to the largest star. Imagine atoms and molecules, the building blocks of everything. These tiny particles are constantly interacting. They're rearranging themselves in a cosmic dance, a constant exchange of energy and matter. A chemical reaction is when these particles break old bonds, the connections that hold them together in their current form. And then, they form new ones, creating something entirely new with different properties and characteristics. It's not magic, it's science. It's how a rusty nail forms through a process called oxidation, where iron reacts with oxygen. Or how a cake bakes, transforming simple ingredients into a delicious treat through a series of complex reactions. You start with reactants, the original materials, the ingredients that will undergo the transformation. Add the right conditions like heat, a catalyst, or even light to kickstart the reaction. And then, atoms swap partners to make new substances, products, the result of the chemical change. Remember, matter isn't created or destroyed, just transformed, it simply changes form. For example, let's consider toasting a marshmallow, a classic example of a chemical reaction in action. The sugar in the marshmallow reacts with oxygen in the air, a process called combustion. All thanks to heat, the energy that drives the reaction forward. The atoms rearrange, creating new substances. It's a molecular makeover, including carbon, which gives the toasted marshmallow its slightly charred appearance, and water vapor, which is why you might see steam rising from the marshmallow as it heats up, ultimately creating that golden brown treat we all know and love. The soft marshmallow becomes crunchy and aromatic, a delightful sensory experience, a clear transformation showcasing the power of chemical reactions. That's a chemical reaction, a fundamental process in chemistry, where reactants become products with new properties, a change in their very essence. Every change in color, texture, or smell, every fizz, pop, or bang, is the result of this atomic dance, this intricate choreography of molecules. Chemical reactions are happening everywhere, all the time, in your body, in your kitchen, and all around the world. They're the reason our world is constantly changing, evolving, and surprising us with its endless possibilities. Science in action, right before your eyes. So keep exploring, keep questioning, and keep discovering the amazing world of chemistry. How can you tell if a chemical reaction has actually taken place? What are the telltale signs that a substance has transformed? Look for clues. Become a chemical detective, observing carefully for any changes. A color change, like a banana ripening from green to yellow as its sugars develop, or iron rusting, slowly turning orange-brown as it reacts with oxygen in the air, means new substances with different properties have formed, indicating a fundamental change. Bubbles or fizzing? Is something effervescing before your very eyes? That's gas being produced. A clear sign that molecules are rearranging themselves, like in a baking soda and vinegar volcano, where carbon dioxide gas erupts. A sudden temperature change, hot or cold, a noticeable shift in the surrounding environment, signals energy is being released, creating heat or absorbed, causing cooling. Sometimes a solid forms unexpectedly from two clear liquids. That's called a precipitate, and it's a sure sign of a reaction. These signs, a change in color, the formation of gas bubbles, a shift in temperature, or the appearance of a new solid where there was none before, prove definitively that a chemical reaction is happening, transforming the original substances. Science is all about observing these changes, carefully documenting the transformations that occur in the world around us. Scientists use chemical equations as a fundamental tool in their work. These equations are more than just notes. They are a concise and precise way to represent chemical reactions. They allow us to describe reactions quickly and clearly, providing a standardized method for communicating complex chemical processes. A word equation spells out in plain language the reactants and products, the substances that go into a reaction, and the substances that are produced. For example, iron plus oxygen yields iron oxide. This tells us what's reacting and what's being formed. For more detail, symbol equations offer a more precise representation. These equations use chemical symbols and numbers to show the exact composition of each substance. Fe plus O2, Fe2O3. This gives us a shorthand way to write the reaction. However, the law of conservation of mass is crucial. It means atoms on both sides must balance. You can't create or destroy atoms in a chemical reaction. Balancing equations uses coefficients, which are numbers placed in front of the chemical formulas. These coefficients ensure the same number of each atom on both sides of the equation, upholding the law of conservation. For water, let's look at its balanced equation. 2H2 plus O2, 2H2O. Notice the coefficient 2 in front of both the hydrogen and water molecules. Chemical equations are the universal language of chemistry, transcending borders and disciplines. They let scientists everywhere, regardless of their native language, share and predict reactions, fostering collaboration and accelerating scientific discovery. Chemical reactions aren't just for labs, they're everywhere. Cooking breakfast? Heat changes egg proteins, a chemical reaction. Breathing? Your cells turn oxygen and glucose into energy, water, and carbon dioxide. Cleaning? Soap and bleach trigger reactions to break down dirt and germs. Batteries and engines. Both rely on chemical reactions to power your devices and move your car. Our world runs on these invisible atomic changes. Every transformation you see is chemistry at work. Science is truly everywhere.